Sat Sri Akal, Namaskar, Adab, good evening. Yes, my dear students, how are you? I hope all of you are very well there. So, in the previous video, all of you learned about LCM of two numbers. All of you had been learned how we can find the LCM of two numbers, and either both of them are prime and one of them is prime, and either none of them is prime. Okay, so how we can find LCM? So today we are going to discuss about HCF. HCF means highest common factor. Highest common factor. It means very firstly, if two or more than two numbers are given there, very firstly we have to find the list of all the factors of those numbers. Okay. Then after we will decide which factor is greatest among them. कौन सा फैक्टर उन सब में से बड़ा है? That's HCF. Highest, बड़े से बड़ा common factor. Is it clear? Yes, beta. So it is very easy concept, and as I had been told you in the previous video, all the numbers which are exist in this universe have one as a common factor. सब में one common factor बेटा, सब में one common factor है. It means if two or more than two numbers have no any common factor, then at least one is the common amongst them. So it means very crucial note we can say that is like HCF can never be zero. कभी भी HCF जीरो नहीं हो सकता, because at least one will exist there. At least one तो होगा. तो HCF at least one होगा. Is it clear? At least one तो होगा, because all the numbers which are exist in this universe have one as a common factor at least. Is it clear? Okay, so then we will decide what is the highest common factor amongst two or more given numbers. For example, if we have 24, then after suppose if we have 14, either 9, so what is the HCF of these three numbers? You know, what are the factor of 24? Very firstly we have to find the factor of 24, and in the replace of 9 I want to change this number. I want to write here just like 16. Okay, so that very easily you can clear the concept. Okay, so what are the factor of 24? 1, 2, mean to say all those number which divide 24 perfectly, leaving with remainder 0. All those number, or the list of all those number are the factor of 24. 1, 2, 3, 4, 6, and then after 8, 12, 24, either 24 included. Okay, then after 14, 1, 2, 7 and 14, and about 16, 1, 2, 4, 8 and 16 by self. Is it clear? So now we have to consider which factor, which is the greatest common factor amongst them. Which is the greatest? 1 is common, okay, then after 2 is common, then after 4 exists here but not exist here. 4 exists in these two numbers but not here. So it means highest common factor is 2. बड़े से बड़ा जो factor इनमें common आया वो 2 है. It means 2 divides all these three numbers. You know beta, what is the connection between HCF, LCM and the given numbers? Listen beta, LCM always divided by numbers. Okay, जिन numbers का ये LCM है ना, ये इन नंबर से, each number से, by each number. तो जिन नंबर का भी ये LCM है, the LCM which we had been taken from those numbers, all those number perfectly divide the LCM. Numbers जो होंगे वो सभी इस LCM को divide करेंगे. कौन से numbers? All those numbers which we had been used to find the LCM. जिन numbers का हमने LCM लिया है. Is it clear? कोई ऐसे नहीं कि सारे number. Means like all the numbers. No. Only the numbers which we had been used to find the LCM. All those number will perfectly divide the LCM. And then what is the relation between HCF and numbers? So listen beta, HCF always divides all those numbers which we had been used to find the HCF. Is it clear? So just you have to consider the connection between the numbers LCM and HCF, and from these two, that's the equation first, that's the equation second. From these two we can conclude that LCM also divided by HCF. It means we can say that HCF is a factor of LCM always. हमेशा HCF जो है वो LCM का फैक्टर होगा. इट मींस HCF जो है वो LCM को परफेक्ट डिवाइड करेगा. Yes. So LCM always divided by HCF. It means HCF is a factor of LCM also. Is it clear, beta? Yes. Then we can prove it by taking some example. Like very firstly, already we had been taken the HCF here. So you know what is the HCF? HCF only 2 here. Is it clear? So we can verify that like all those numbers which are taken here, all these numbers are divided by HCF or not. So very easily you can clear it. Like 24 divided by 2, that's perfectly leaving with the remainder 0. Okay, 14 also divided by 2, leaving with the remainder 0, and 16 also divided by 2, leaving with the remainder 0. It means it is verified that all the numbers, all those numbers which we had been taken to find the LCM or HCF there. Okay, yes, all those numbers are divisible by HCF always. So in this way you can verify the LCM also. So how we can? So now either we will discuss about like if we have to find the LCM and HCF taken together, how we can find it. Okay, that's the question related to the 10th standard in first chapter. Okay, yes. So now we are going to take some examples. Like same number we can take there. If we taken here 27, like 24 and either 15. Okay, so I had been changed this one. So very firstly we have to find prime numbers, prime factors. So prime factors are 3 and then again 3 and then again 3. Okay, 24, now it goes to 2, then again 2, then again 2, then 3. Okay, 15, 3 and 5 only. Is it clear? Okay, so how we can find the HCF and LCM? So very firstly HCF. So what is HCF? You have to find the common prime factor amongst all these. Okay, so 3 one time is common. Okay, so is there 2 or 5 common there? No. So it means HCF is 3. So either you can find it in this way. 27, you have to write firstly all the prime factors against all these numbers. 27 has the prime factor as 3 into 3 into 3, and either 24 has 2 into 2 into 2 into 3, and 15 has 3 into 5. In this way you can consider easily like which prime number is common there. Okay, so now you can easily consider that 1 time 3 exists in all these numbers. Okay, so that's why it means all these 3 numbers are divisible, as we had been considered previously and we has been learned previously. HCF will divide all the number taken there. Okay, yes, so it means 3 divide all these 3 numbers perfectly, leaving remainder with 0. Okay, so now it's the turn to find the LCM. So how we can find the LCM? Already you had been learned in the previous video, part first, that's the part second. Okay, so it is very easy. We have to consider smallest prime factor firstly. So smallest prime factor is 2. So 2 consider there 3 times. So 2 into 2 into 2, and then 3 consider as 3 times. Okay, and then 5 only 1 times. So it means it is very easily. Listen beta, it is very easily. 3 times 2, 3 times 3, it means 6 into 6 into 6. It becomes 6, it becomes 6, it becomes 6. And you know 6 into 6 into 6, is it equals to 216? And now very easily you can find the product of 216 and 5. Okay, so it is 3 and then 8, 1080. Is it clear beta? Yes. So LCM is 1080. So it means, now it means all these numbers will divide 1080 perfectly. जैसा मैंने बताया था कि एलसीएम को वो सभी नंबर्स जिनका हमने एलसीएम लिया है वो सभी नंबर्स परफेक्टली डिवाइड करेंगे. ऑल दोज नंबर्स व्हिच वी हैड बीन यूज्ड टू फाइंड द एलसीएम will divide the LCM perfectly, leaving remainder with 0. Is it clear? So now you can verify it. So very easily we can verify it. It is very simple. 1080. Very firstly we will divide it by 27. So 27 fours are 108 and 10 is there. Okay, it means it should leave a remainder as 0 and it goes to 40. It means 27 40 is if we taken 40 times 27. Is it clear? It means you can take 27 as 40 times, then it will give 1080. Is it clear, beta? Yes. Now if we consider the next number, if we divide 1080 by 24, then how we can perform this one? So 24 fours are 96 and then it goes to 5 and again it also leaves a remainder as 0 and finally now we will divide it by 15. So 15 sevens are 105 and 2s are 30. Okay, is it clear, beta? Yes. So it is very easy. So if we will take 40 times 27, then it becomes 1080. If we take 45 times 24, then it becomes 1080. If we take 72 times 15, it becomes again 1080. So very easily you can consider that in all these three conditions, when we divide this LCM by the given numbers which we had been taken to find this LCM, so all these numbers will leave the remainder 0. It means perfectly divide. Is it clear, beta? So yes, that's the verification. I hope all of you understand this concept.